except I don't want to have 2 through 6. I really want to have 1 to 5, right? So what can I do? I could move these around, but the easiest way to do that is just to change my initialization and initialize count at 0. Then once it goes through, count is going to be 1. So now I execute the script, and this is okay, but now I've gone bigger than 5. So, well, what can I do here is get rid of the equal sign and run it, and now I got my 1 through 5. So this is the first part of my program, because now I just want, as I loop through, instead of looping through, I actually want to multiply the values, right? So each time count is, first time is count is 1, then it's 2, then it's 3, then it's 4, then it's 5. So what if I have a new variable, and let's call this the result. It's going to be the answer. And let's assign this to 1, initially y1, because I'll be multiplying this together, and if I say 0, it's always going to be 0. You multiply any number by 0. So now I'm going to have my idea here, and I can say my result is equal to result times count, because that's the number that I'm going through. So now let's go ahead and instead of printing the count, let's print the result. So let's try this and see if I'm getting closer to getting my answer. By the way, 5 factorial, if you multiply all these together, you get 120. So let's run this, and we see, oh, as I loop through, I get 1. I loop through again, 2, 6, 24, 120. So that is the answers. So the only thing I need to do now is I really don't need to print all the way up to here. I can move this back. So I only print it once. I only print the final answer. So let's run the script here, and I just get 120. So now I can try different things. Let's try to find the factorial of 6. Okay, well, that's a bigger one. It's harder to figure out. Well, I got to take 120 times 6, and yeah, that's 20. Let's choose an easy number like 3. So what's 3 times 2 times 1? Well, 3 times 2 is 6. Let's run that, and you get 6. Okay, a little bit easier. 4, that's a pretty easier one. 4 times 3, that's 12. Times 2, that's 24. So I run this, and I get 24. Okay, so you can do the math and figure it out. And so now let's just try a bigger number, and we can see how big factorials get. So I can try 10, and wow, that's getting big. And then let's try 50. Okay, at a certain point, the number is going to be so big that it will break the program. Oh wow, that's a pretty big number there. So we can see that, and at a certain point, again, the numbers get too large that it can't. But let's choose something a little bit smaller, a little bit more practical, and run this, and we get still a very large number. We can move this code back out to indent it so we can see how it's getting bigger each time. Let's try this. So here we can see 1, 2, 3, 4, 6, and we can just see getting bigger all of each time. Okay, so you looked at a practical example of a while loop using calculating the factorial, and we've tried to break the problem up instead of just starting like I'm going to write all my code and then test it at the very end. No, we want to slowly build it up, break the problem into parts, figure out exactly what our inputs are, what we need to know, and it's very good just to write those out and before we start designing our algorithm. And then slowly, as we begin to write your code, you write small parts of it, you test it, and you make sure that's all working, and you Welcome back to our beginning Python course, and today we're going to be looking at the while loops, another application of while loops, specifically building a table of XY coordinates, or for example building a conversion table between centimeters and inches, or a conversion table between Fahrenheit and Celsius. It could be used for a wide variety of things, and they all follow a similar pattern. Number one, you want to have a start point, an end point, and an increment amount, and then you can do some calculations within your loop. So let's go ahead and start with this idea. So the idea is I want to build a table of XY coordinates for a line. And let's say our line is, it could be anything. It could be linear, or it could be a nonlinear. It could be, for example, any type of function, but it could be a polynomial. But let's say y equals 3x plus 2. So we'll use a basic line from our algebra example, and we say, so what do we want is we want a start x, or start point. I'm going to call it start x, and I'm going to make it equal to -5. And let's make these floats. And I'm going to need an endpoint, so I'm going to call it end x, and that's going to equal to 5.0. So the idea is I want to increment between -5 and 5, and I want to find out, those are the x values, and I want to see what the y value is for it, so I can now plot my lines, plot my xy points, and do a line. draw a line as for an algebra assignment. So the next thing we need to do is, so we have our x, y, and we need to increment x value. And I'm going to start off by making it 1, but we can adjust this as we go along. So in other words, I'm going to go from -5, and I'm going to increment by 1, so I'll get -4, -3, -2, -1, then to 0, and then go all the way up to 5, incrementing by 1. And I'm going to calculate. Now I want to do a for loop, a while loop, in order to get through this table. So the first thing I do, those are my initial values, and I now need to say, I need to assign x, that's going to be my value that I iterate through the loop. I'm going to start it off at the start x, because that's where I want to go. So I can say now while x is less than the end x, this is a conditional, so x is less than the end x, because then I want to do y is going to equal to my function, which is going to be 3 times x plus 2. So that's my function, and now I can increment x, so x is going to equal x plus the increment, and now I can print both x and y. So now in order to print x and y, I can go, well, what I want to do is put a little space between them, so I really need to do a data conversion here, because x is going to be a float, and I want to do a string concatenation here. So I'm going to go string, this is a string, it takes the value of x and puts it into a string so I can print it, and then I'm going to put some spaces, and then I'm going to do a string again and do y, so I can print my x and y coordinates here. Okay, so basically this is just a data conversion. Data conversion, it takes this value of x, which is
이놈식 진짜.
is a float, turns it into a string. Same thing with y, turns it into a string, and now I'm going to have a string concatenation off at the start x, because that's where I want to go. So I can say now while x is less than the end x, this is a conditional, so x is less than the end x, because then I want to do y is going to equal to my function, which is going to be 3 times x plus 2. So that's my function. And now I can increment x, so x is going to equal x plus the increment. And now I can print both x and y. So now, in order to print x and y, I can go, well, what I want to do is put a little space between them, so I really need to take and do a data conversion here, because x is going to be a float, and I want to do a string concatenation here. So I'm going to go string, this is a string, it takes the value of x and puts it into a string so I can print it, and then I'm going to put some spaces, and then I'm going to do a string again and do y, so I can print my x and y coordinates here. Okay, so basically this is just a data conversion. Data conversion, it takes this value of x, which is a float, turns it into a string, same thing with y, turns it into a string, and now I'm going to have a string concatenation. I got a string plus some spaces. Just to make it look a little bit neater, I put some spaces in here. So let's go ahead and run this loop and see what we get. Let's execute the script. And I get -4, 13, -13. And this is basically, if I plot all these points, I would be plotting this line here of y equals 3 times x plus 2. So this exact same idea can work with conversions between inches and centimeters, or Fahrenheit and Celsius, or any type of, or a parabola. And so go ahead and try this idea. Again, what do we need to do? We always have to have a start point, an end point, and an increment value. So what can I do? I can actually change this increment value now to 0.5, and we'll see that we'll double our number of table amounts. See, so it goes every half point instead of every one. Or I could change this to 2, and then it's going to be even fewer. So we can adjust this, or I can adjust the endpoints. I can go take this endpoint all the way to 10, so we'll go farther. So with these three values, I can just always adjust them, and I can change this line to use a more complicated parabola or some other type of polynomial function. So that's an idea. Look at the problem sets. There's a lot of examples here of conversions here. But basically, if I did a conversion between Fahrenheit and Celsius, I would just need that new formula. I would have to look at the formula. How do I convert between Fahrenheit and Celsius, and put it in here, or between centimeters and inches? Whatever your equation is going to be. If I'm doing something to do with gravity, I need to calculate the distance, knowing what gravity is, and put that formula in there. So go ahead and look at the problem sets, and then that will give us more examples of using this template to run these calculations. Thank you.
어, 와. 아니, 아까, 어? 아, 유리 남편이야? 아, 진짜? 나 몰랐어. 내가 부른 게 아니거든. 우리 거기 페인트 사장님한테 불러달라고 그랬거든. 어, 어. 아, 진짜? 그럼 왜 얘기를 안 해? 난 아직 카톡을 듣기는. 차에 앉아있겠대. 나 집에 와. 시간이니까. 몰랐네. 몰랐어. 아야, 나 아이패드 키는 거 때문에. 한경아. 너 까만색 아이패드 너가 쓰는 거잖아. 하얀 거 오빠 쓸게. 이거 오빠가 초기화 시켜야 될 것 같아가지고 전화했어. 오케이. 안 되는데? 됐구만.
Welcome back to our beginning Python course, and in this lecture we will be looking at the Fibonacci. Fibonacci series. And the Fibonacci series is a series of numbers that starts off with 0 and 1, and the next element is always equal to the sum of the previous two. So we have these two first elements, and then 1 is equal to the sum of 1 and 0. Now you add these two up, and you get 2. Now you add these two up, 1 and 2, and you get 3. And you add 2 and 3, and you get 5. And it continues all the way up, and you can print out as many elements as you want of the Fibonacci series, because it obviously goes on forever. So how are we going to do this in a while loop, which we've already learned about? The idea is, let's start off by just printing the first 5 elements of the Fibonacci series, and then once we get that working, we can increase the elements. So what do we need? Let's think about all the inputs. We're really dealing with 3 numbers at one time. We got n1, we'll call this n2, and then we got n3, right? So let's start off with that. n1 equals 0. We're given that. n2 equals 1. So we're given the first two, so how do I calculate n3? Well, I could just write n3 equals n1 plus n2, but I really need to put this inside of a loop, because I want it to be able to do as many elements as I can in the series and make it very functional. So I need a count, because I'm going to start off by saying count is equal to 0, because I'm going to print out, let's start off with the first 5. So how would I do this loop 5 times? I would go while count is less than 5, because we're going to do it 5 times. So then I have my, this is my conditional, and now I can write what's inside my while loop. So the first thing in my while loop, I need to increment count. So count is always going to equal count. In this case, I'm just going to increment by 1, because I want to go through this loop 5 times. And the next things I need to do is figure out, well, it makes sense, I need to figure out the next element. I got n1 and n2, so n3 is going to equal to n2 plus n1, right? So now I can print n3, because that's what I'm looking to print the next element in the series, and that works fine. And the next thing I need to consider is, well, now I printed n3, I've calculated what n3 is, here's the third element. So now I want to reassign, I want to figure out this one, so that I can reassign these two to the previous ones. So, and this, you have to be careful about which one you're overriding when, but if we go n1 is now equal to the value that n2 is, because I'm reassigning it. And similarly, n2, the new n2 is going to equal to the value of n3. Then as I continue this loop, I'm just basically resetting these back 1 so I can figure out the next n3. So let's go ahead and try to run this program and see how it works. So we get 1, 2, 3, 5, and 8. So we're getting the 1, 2, 3, 5, and 8. Right? So if I want to increase the first two, I can just go print n1. This is at the beginning, before there's any loop, so it's just going to print that value.
네.
Print
그래요?
2. So this will give me the first two in the series. And now I can increase this. I can go a little bit farther than 5. Let's go 10 and run this. Now I got 0, 1, 1. Adding those together, let's go 0, 1 gives us 1. 1, 1 gives us 2. 2 and 1 gives us 3. We go 5, and we can see that gives us 8. And 5 plus 8 gives us 13. And we can see the formula increasing. So let's actually just go, let's try to make this 20. And let's see what our Fibonacci series shows. It just gets larger and larger and larger. And now let's go 50. Okay, and we can look at our Fibonacci series, and it's getting very big very quickly. So, what have we done? We've used a while loop. We decided how many elements of the Fibonacci series we want to show. In this case, it's 50. We increment our counter. We calculate n3. We print n3, and then we reassign n1 and n2 to the next elements in the series so that we can get the next n3, and we just continue to loop through until we are done. Today